Okay, hey, Ashley had a question about standard deviation and how we use it to predict things, population. It's actually not the standard deviation. If you think about a normal curve, right? A little bit of standard deviation here goes a long way to change the population. So get out here, a little bit of standard deviation, or a whole lot of standard deviation doesn't do much to change the probability. What Ashley was probably thinking about was this thing called the z-score. And that's equal to z minus the point of interest minus the mean divided by the standard deviation. So in the case I gave her on the online, I said we have a process that's running 6.32, and the standard deviation is equal to 0.52. And when I said, what's the probability of finding a piece that's less than 7.14? So what I do is I take the point of interest and do the z-score here. I take 7.14 minus my standard deviation divided by, or minus my mean divided by the standard deviation, and I end up with a z-score of 1.58. Now what I do then is I'm going to give you a copy of the standard normal table, standard deviation, or standard normal table. And the way this works is, on the table you're going to see two things. You're going to see this thing called z. It's going to come across, and it's going to 0.0, 0.1, on down. I'm going to come down to 0.5, then I'm going to come across to 0.00, 0.01, to 0.8. And where those two meet, that's the number I want. Well, this happens to meet, that number turns out to be 0.9429. Now what that's telling me is that 7.14, the area underneath that's the shaded area, turns out to be 0.9429, okay? Or 94.29. That tells me 94.29% of my population will be 7.14 or less. Okay. Conversely, since the area underneath the normal curve is 1, I know the probability of going greater than 7.14 is equal to 1 minus 0.9429, or 5.71%. Again, I'll send you the copy of the standard normal table, and also look at what I had on the online when I answered to Ashley. Any more questions, give me a call.